Is there any Chinese module that has no analogs or that is unique that can be used in our various do-it-yourself projects and sounds better than others? Actually, I found one like that, so let's take a look at it. Up close, this is how it comes packaged. I wouldn't call it professional packaging at all. Why isn't it professional? There's no electrostatic discharge bag. It should be in a silver bag. But the unit itself is very interesting. And what makes it so interesting? It's interesting because it contains 4 channels. It can be configured with a balance and also in balanced mode. This is very good because if we can configure it in balanced mode, we can also use professional equipment. For example, a professional crossover for speakers, right? Professional crossovers are produced on a large scale and they are cheap and good. There are also professional digital crossovers and their functionality has no limits. You can solve almost any task with this crossover, but for our task, an analog crossover is enough. Visually, everything is done neatly. They use NE5532 operational amplifiers and 2 TPA3255 chips. The output filters are rated for about 150 watts, but if you look at the size of the heatsink, it's kind of on the edge. I'd say 100 watts in various options. We can use 250 watts per channel, but I doubt it. Basically, then you need to install a fan and blow it through, then you can do 250 watts too, but overall this unit is designed for an output power of about 150 watts, I'd say. That's not bad either. Let's say 150 watts per channel. But let's say it's about 100 very clean watts. For mids and highs, that's just right, yeah. So one of these units can handle a stereo setup for mids and highs, or a pretty decent two-way system as well. So in that regard, this unit is very good. It's low profile. Well, the first thing I check is how the thermal management is done, how well the heatsink fits against the surface of the chip. That's important. That's very important. Let's take it apart. I've already done it here. So what? It's good, it's fine, it's solid, it's done right. We have thermal paste. Also right here, you can see there are even milled grooves, so everything fits well. It's done properly. Well, where can I raise my concerns? Look, if it's a heatsink, the heat spreads well across such a thick surface, but here they cut corners. The chip should have been here, then it would have been perfect, but they probably saved about 5 millimeters on the board and placed it like this. But overall it works. Overall it works, and I don't have any serious complaints about it. The cooling is done properly. This immediately gives us a long service life. When the thermal management is done correctly and properly, that's excellent. What else? I put it in a little bag so I wouldn't lose it. There are these plastic washers that limit the height. This means we can tighten the screws pretty firmly and the heat sink will stay securely in place. Yes, even on both sides we have these little washers. That's smart, that's important. So where did they save money? They really saved on the big capacitor, but everything here is still done properly. These small ones, which are close to the microchip, they react to the first volt when there's a sharp impulse like that. They're close to the microchip, so the resistance of the tracks is low and they immediately deliver the first response. But if we want to get more power, we put a big capacitor outside. Let's look at the reference design and see if we can find any familiar components here. So here we have a circuit, the so-called reference design. Or, it's hard to translate, but this is how it should be done according to the manufacturer. What do we see? We see that at the input they suggest A good operational amplifier, NE5532 for audio. It's a very good amplifier. But the standard parameters we see are the input ones. They did this for, well, future developers, kind of a basic solution that fully meets all the parameters that this chip can provide. And with different jumpers, we can create configurations. For example, here is a jumper that lets us switch from unbalanced to balanced or differential inputs. What do we see here in the chip? The same thing and the same operational amplifier. So everything here is done according to the reference design. Nothing was invented. It's a reference design and we configure it. That means it will definitely work. It will definitely work because there are no special innovations here. Well, as you can see, we don't have these large capacitors on the board here. So if we want to use it purely as a power amplifier, we add them. But if we use this board as an active system, a three-way active system, and only for mids and highs, then it's not that important. At mid and high frequencies, well, mainly at mid frequencies, our hearing is very sensitive. I would say that this board will work in the range from 0.5 to, well, okay, I'll be very conservative. Up to 10 watts. I think up to 5, and the same goes for the buzzer, since in the audio spectrum the buzzer operates at low power. So we'll have a huge power reserve, and we might not even need to install these capacitors and everything will be fine. If you're making a full-fledged amplifier on this board, then yes, you need an external capacitor, but in such an active system you don't. So what else do we have on the board? On the board we have a voltage converter, let's say from 50 volts down to 15 volts, and then we further stabilize those 15 volts with a linear regulator. This way we have the very best power supply. Here it is, set to 12 volts. Let's take a look at the board now. Look, here is our converter, modern and quite powerful, a good 12-volt stabilizer. This one will definitely work without any issues. It can handle 1 amp. We don't even need that much. But everything is done, in my opinion, competently, really competently. They didn't invent anything. They just took a reference design and simply made this board. Why did I choose this board? Well, let's say all the other boards that we see in Chinese designs on AliExpress, on the TPA3255, they keep changing. This unit has been stable for at least 3 years, I think. That means they did something right. And I also chose this unit as a good one. It has no analogs, and it solves a serious complex problem, especially since they can be used in both balanced and unbalanced configurations. It seems like a small feature, but it immediately expands the application to all areas and also allows us to use professional equipment to achieve different solutions. And in the professional industry, the policy is a bit different. There is a small range of solutions there. Well, for example, the same active crossover. There are 2 of them, but they are so polished for use and produced on a large scale. We get quality, functionality and price all in one. If we look at the end user market, such equipment would cost thousands, but professionally it costs hundreds, and we can create different solutions using a hybrid approach. We can take something from the professional side and something from the end user, from the high end. Well, let's put everything back together and take the key measurements. What am I not going to measure? I'm not going to measure non-linear distortions. We're not interested in those at all. Basically, all the components used are industrial, and everything is determined by the chip. The chip is original. There's no copy here. The Chinese don't make anything. And in this case, making a copy would be very difficult and makes no sense at all. So, as far as the parameters go, everything will be fine. But what do I want to see? I want to see how the filters are set up. That's the main thing. I want to see the input capacitors. Did they do everything right there? Or are they limiting the low frequencies? And I always check these two key things. If they don't pass these, then these units, I don't recommend them. Well, so what did I do? I carefully removed the paste, washed off the previous one, checked under the microscope to make sure everything was fine. Well, I did the same thing with the heatsink, but no microscope. Well, and since I don't have such good paste, I'll be using so-called thermal pads. Well, it's the same as paste, but in a slightly different form. This is German paste. I bought it on AliExpress. There's even some Russian written here. I picked it on purpose. I have one like this with Russian labels. And what do we see here? So the hardness is determined by how blurry it is, but that's normal for this application. Then the breakdown voltage is 9.8 kilovolts per millimeter. This is 0.5 millimeters, so half of that. Well, that means we'll have, well, roughly speaking, it holds 5 kilovolts and I need 50 volts. Not a problem. Yeah, in this case it's not a problem. So what else? Thermal conductivity, let's call it that, how well it conducts all this heat. And overall they're from 9 to 20 watts per meter Kelvin. 21 is very good, very good. Usually it's, I don't know, 5.9, but 21 is very good. I know exactly what I can use. It says here the size and what thickness it has. Well, it looks like that. It's not cheap. Yeah, it's kind of sticky. I'll cut 2 pieces from it to use instead of thermal paste. That'll be easier for me. I'll try to do it like this, about the size of the chip, maybe a little bigger, and then everything should be fine. Alright, it's time to assemble the unit, but I'll be using this board for various experiments. I want to determine exactly what voltage this unit can operate at. Because without a fan, it definitely won't handle 48 volts. That's why I'll be disassembling it, applying different thermal pastes and checking how it all works, what affects what, and what the temperature is. That's why I'll replace all these washers with this kind. A pad for a transistor outline 220. That's a standard large transistor. And for this, I drilled these screw holes a little bit bigger. And then it fits perfectly. And it, considering the thickness, of the circuit board, it makes a perfect spacer. I can easily install them and tighten them pretty firmly if needed. That means I'll have the best thermal contact for experiments. In general, this whole system needs to be reliable. If you use 2 washers there, it will be a lot of work. And look, if you install it like this, you don't need to do anything on this side. I can just easily fasten everything, and to make it even easier, I have these small vices. I'll just secure it. And then everything will become really simple. Don't tighten everything at once. Do it gradually. Once all screws are in place, we tighten them carefully one by one. The thermal pad is flexible, it has some elasticity, it will fit snugly and firmly against the chip, creating excellent thermal contact. Regarding this board, the factory solution is good. There's nothing that needs to be changed here. I'm usually skeptical and always check if everything is okay, but with this board, everything is fine. This is just another reason to say that this board is good, since you don't need to make any modifications at all. The one I made as an experiment, so that I don't have to screw in those screws or look at those washers. It's inconvenient, but good for experiments. It simplifies everything, but overall everything is done properly. Let's measure. Well, let's do the main measurements. I'll be using a signal generator or a measurement signal generator. As you can see, this is Tektronix, and I also have a load equivalent where I can turn the load on and off. This allows me to apply the load only during measurements and to supply a sine wave for a short period of time to measure maximum power, peaks and more. And we'll also look at the amplitude frequency response at 8 and 4 ohms. How will I show it? I'll just show the oscilloscope screen and comment on what I'm doing. It will be quicker and simpler. So here we have the oscilloscope screen. I have a good Fluke oscilloscope. 199C, it has one feature. It has, in English, they're called floating probes, well, isolated probes. That means I can measure a bridge amplifier circuit right at the output. If you have a simpler oscilloscope, you can't do that because you'll short one output, and in a bridge circuit, both outputs are hot. But then you measure in such a way that you connect one probe to ground and measure on one output and then on the other output, and you'll see half the voltage in one polarity and in the other polarity. Here I can just measure everything, but if you have a simple oscilloscope, don't do that. Alright, first let's turn it on. I'll be using a power supply with protection. I always check if everything is okay with the power supply. It has protection, so nothing will burn out turning it on. And as you can see, there's about 8 volts of output voltage. So at the output, this is the input voltage, this is the output voltage. I'll be monitoring the frequency at the input so we can see different values. And the blue one, that shows us what's at the output. For this particular board, I'm only interested in 3 things, and I won't be measuring harmonic distortion. I'm not interested in that. Since there are standard factory output filters here, a standard chip, everything here follows the reference design schematic. Whatever the chip gives, that's what you get. But what am I interested in? I'm interested in the tuning, in what load this particular unit is set for. And for that I'll apply a variable signal from 20 Hz to 20 kHz. And we'll see what it looks like and how this unit behaves under different loads. So here I have this unit with no load. And let's see what happens at 8 ohms. So, well, it's almost linear. It dropped just a little bit. That means this unit is set for 8 ohms. And what about 4 ohms? Well, you see it's already a little bit more, but that's within about a decibel or so. Yeah, that's not a lot, but in any case, it's set for 8 ohms. Since I'll be using this unit in multi-channel mode, let's see what the linearity is like within the pass band. So, I'll start with the mid-frequencies from, well, let's say from 350 Hz to 4.5 kHz. So right now I'm measuring from 350 Hz to 4.5 kHz, and overall I'd say it's absolutely linear. Yes, the amplitude response here is perfect, so it's perfect at 8 ohms and also perfect at 4 ohms. Basically, almost nothing affects it. And now let's see what we have in the high range from 4.5 to 20 kHz. Right now at 8 ohms from 4.5 kHz to 20 kHz. Well, there's an interval here too. You can see it. Sometimes they're shown in the middle, but overall almost nothing drops. If I use this unit in a multi-channel system, it's almost perfect. What about 4 ohms? Well, at 4 ohms there's a little bit, but we won't hear it. It will be 0.5 decibels at 20 kHz. Although I like those units that are set for 4 ohms or 6 ohms. This one is set for 8 ohms. But if it's an 8 ohm tweeter, well, it's almost perfect. Also keep in mind, if you look at the impedance characteristic of an 8 ohm high frequency speaker, it goes up to 10 or 12 ohms. And basically, the amplitude response will be absolutely perfect. What else am I interested in? I'm interested in the lowest frequencies. When we put capacitors at the input, people often try to save money. You can see that the signal isn't very good. But first I'll look at the square wave at 8 ohms and at 4 ohms. At 1 kilohertz it's perfect, and now I'll check somewhere around 100 hertz and 50. So here at 100 hertz it's good, but compared to 50, well, there's practically no effect. The fact that it bends a little there is completely normal. With a sine wave, everything will be fine. Let's also check the linearity at low frequencies where we have capacitors. This is this signal, and it's almost perfect. It's like if the capacitors are too small, this signal bends right away. Let's look at 20 at the limit, and at 20 hertz, you see, it becomes just a little bit exponential, but in this case, everything is fine here. If it were that obvious, or if it bent a lot, then we could say that there are certain problems at low frequencies. But here everything is clean. It's a very good unit. All the components are selected just as needed, but not lower. If you look at the sine waves, of course, everything is perfect, but this is a test signal that shows the presence of coupling capacitors. And it often happens that Chinese units try to save money. They put some, well, like a ceramic capacitor with a large rating, but they're too small and all the problems show up right away. And what happens then? You turn it on and everything seems fine, but something's missing. Something's missing in the lows. There's bass, but it's kind of weird. In conclusion, it's a very good unit. It has outlasted at least 4 generations of competitors. It's always produced exactly the same as it is. But the last unit I bought, this unit has slightly improved thermal characteristics. The way the heatsink is made. These small things are actually important. Measurements showed that everything is fine, and in my designs I will use this unit for mid and high frequencies. And for low frequencies I'll pick some industrial unit with power up to 500 watts, and then it will provide any solution, any speaker. Basically, my focus is on a 3-way speaker, but one such unit can power 2 two-way speakers very well. It can also power, there are speakers like that where there's a tweeter, a mid-range, and then 2 woofers. If you drive 2 low-frequency speakers from each channel, it will also work very well with one such unit. But if you go with that solution, then you need to install a large external capacitor for the woofer, so it can deliver peak power. Since, of course, they saved money on the capacitors here. But that was the idea. If you put 2 large capacitors here, the board would be bigger. And if the board is bigger, there are integration problems. I think this design is successful, very successful. I like it. And it occupies a niche where there are no others. That's the most important thing when there's a lot of competition, to make something that others don't have. And I think I will also create a product based on this unit. The price is also affordable. Well, it depends, around 50 to 60 euros. That's a good price for this unit. Don't be greedy. And also what's important for me is that you can configure both unbalanced and balanced connections. I will use it together with personal equipment. That's a balanced connection. That's important for me. Also, what I like is how these outputs are made, or how the inputs are made. So you can place it close to the edge of the case. You end up with these short wires. And I can even get a configuration where I need to shield the wires. Yes, if it's somewhere up to 5 centimeters, then it's not a shielded wire. It's shorter than a shielded wire where we strip the ends. Yes, there is still some amount of unshielded space there, and in that case I can use unshielded wires. And a shielded cable, well, it's expensive. It's expensive to produce. In any case, it's almost all manual work. There's no full automation there. Unshielded wires are produced automatically. Yes, you save money right away. You save money right away. Such small things during development are important. You have to think about them. As soon as you have some volume, all this costs money, and that's where we benefit. Overall, I recommend it. It's a good unit in every way, and no modifications are needed. You just install it, connect it, and it works. The second serious experiment I did regarding temperature characteristics, and even though this is a good solution, the heat sinks are still not sufficient to operate at 48 volts in a closed room, in a closed case. It gets very hot. Yes, it won't break right away, but basically it heats up a lot. And that's why if you're building some kind of device, you need to position it vertically. That means you'll end up with a greater height, but then it's possible. Then there's convection, cold air below, hot air above. Convection ensures everything works. If not, then you need to install some kind of fan and extract the air, or blow on it, or do something else. In general, I recommend up to 42 volts. I don't recommend 48. Personally, I will use 36 volts, and then it will work for me. Well, not forever, but for a very long time. Well, I know you will ask if I recommend this unit. Yes, I recommend this unit. Overall, it's a good unit, a good Chinese manufacturer. Everything is well made, and you can safely use it in your projects. You can make a good two-way system. Yes, both channels here are quite specific. Three-way systems where there are two powerful woofers and so on. In general, it has many applications, many uses, in my opinion. For me, it solves a rather complex task. A budget active system. It fits right into this niche. That's why I'm praising it. If you need pure power, yeah, this isn't the unit for that, but it's just right for active systems. Overall, I recommend it.